All right. Hello. This is Group 17. Our project is on why golf balls have dimples. All right. Back in the 19th century, two golfers decided to play around. The first one used a brand new shiny ball, and he sent the ball flying 150 yards. The second player used an old dinged up and scratched ball, and he sent the ball flying 225 yards, while all the other conditions were the same. So, why would the old scratched ball fly further than the new shiny one? Alright, so we know that the drag force is going to be equal to the drag coefficient times the density times the speed of the object relative to the fluid times the area divided by 2. And we know that the density of the shiny ball and a dimple ball are the same, the speed is the same, and the area of both balls are the same. All right. When a golf ball got hit and flew in the air, two types of flow was present around the golf ball: laminar and turbulent flow. Now, laminar flow has less drag, but it is also prone to a phenomenon called separation. Once separation of a laminar boundary layer occurs, drag rises dramatically due to eddies that are formed in the gap. Turbulent flow: the dimpled ball creates very small amounts of turbulence, and turbulent flow comes with more drag. However, it has better adhesion, and this adhesion causes air to remain in the boundary layer longer. This results in the airflow separation that will occur later on the ball, with fewer eddies forming and less force trying to pull the ball backwards. Therefore, if the shape of the object has separation, easily like a perfectly smooth golf ball, it is better to turbulent the boundary layer to increase adhesion of the air to the ball and reduce the number of eddies formed and drag force. All right, some of our example calculations, what we did is we knew that the kinematic viscosity of air is equal to 14.8, or 14.8 times 10 to the minus 6 meters squared per second. At a speed of 50 meters per second, a golf ball with a diameter 5 centimeter or 0.05 meter has a Reynolds number of 67,400. Calculate the drag force experienced by the golf ball. Now, we took the solution to that, and we found that when we look at the drag coefficient versus the Reynolds number graph, we get a drag coefficient of 0.23, and the area of the ball is just going to be pi times the diameter squared over 4. So we got a diameter of 0.001964 meters squared. Thus, we know that the drag force can be calculated using this expression on the bottom, and the force was equal to this equation over here. For the ball with dimples, we got a force of 0.0136 newtons, and the one without dimples, we got a force of 0.0300 newtons. So the ball without the dimples had a greater force than the ball with the dimples, almost double the force, a little bit larger than double the force. Conclusions. We know that came to the conclusion that laminar flow has less drag, but it's prone to a phenomenon called separation. Turbulent flow experiences more drag initially, however, has better adhesion, causing the air to remain in the boundary layer for longer. A higher drag coefficient value, CD, would always result in a higher value for drag force, and that can be determined by the Reynolds number graph and using it on the drag coefficient versus Reynolds number. And we know that a golf ball that has dimples on the surface experiences relatively less drag as compared to other sport balls.